So the second subpart is supply adjustment. And this is very important also to understand. So let's get started. So in the word cloud, you probably remember the word burn. We know what burning is, but what is burning in DeFi? Well, it's simple. It's reducing supply. So you remove it from circulation. So it's actually similar to what actually happens with physical currency when it wears out. The worn dollar bills are actually burned and new ones are printed. Okay, so there's different ways to do burning. And you could basically send the token to an unowned Ethereum address. Okay, so that's an address that nobody's got the private key for. And a better way to do it is to send to a contract that is incapable of actually spending the token. So there's no way to spend it, so it just sits there forever. And I say it's a better way because I mentioned the possibility in the future of potentially going the other way from a public key to a private key. So the unowned address potentially in the future could become owned. So it's much better to send to a contract that is incapable of spending. And there's no way to modify that contract. So the contract's there. It's got no mechanism to change the very important property of no spending, and is there forever. In the Ethereum blockchain, it is immutable. Okay, so basically what happens here, so obviously when you burn, that token does not become usable. Okay, and maybe that's a little curious to think about. So we understand in centralized finance why you do this. Well, the cash currency just gets worn out, it's torn, tattered, and then we replace it. This is different. We're just burning. And kind of what would you want to do that for? So we'll explore that. And there's also burning mistakes. So it might be that you think you're sending to somebody some Ethereum, but you send to the wrong address. And that address might be unowned. And that Ethereum's gone. Okay, so that's basically what I call a burning mistake, where you basically burned your own Ethereum. So there are various different mechanisms to reduce the possibility that this happens. There's the EIP 55, which you can look up. So that's EIP is Ethereum Improvement Protocol, number 55. And it's actually suggested by Vitalik, and it's very elegant, and it's basically a checksum. So when you put your address in that you're sending to, there'll be a check that's run, and it will flag most of the time if that address is invalid, because it would not pass the checksum. Okay, so, and that means that the transaction fails. Okay, so this happens before, so think of this as the checksum is done. If it fails, then there's no transaction. Okay, and remember, all transactions are atomic. So if it fails, you resort to the original state, like nothing has happened. So this is something that Ethereum's got, that Bitcoin's got. Most cryptos have a checksum capability. Nevertheless, you can still make mistakes, and many have lost their token due to a mistaken burn. So why would we burn? Okay, so it turns out it's pretty simple. Think of like an equity token. So you represent, let's say, 10% of a pool. Okay, so there's a pool that has got 100 Ether in it, and you've actually contributed 10. So you've got 10% of the ownership of that pool, and there's a token that's issued to you that basically represents 10% of that pool. Well, suppose you want to redeem the 10 Ether. Well, no problem. You send in your token that's worth 10% of the pool, and 10 Ether transferred to you, and the token that you sent is burned. So you no longer own 10% of the pool. It's gone. It's burned. Okay, so this is like one application in terms of redemption of a pool. We talked about in the this first course, this change in Ethereum that will likely happen where the base gas fee will be burned. Okay, so instead of going to the miners, the gas in Ether will be burned, and that will serve to kind of reduce the inflation in Ether and potentially make it more valuable. So there's other possibilities here. So burning is used in some protocols to increase value. And the idea here is if there's fewer tokens out there, then the value should actually increase. And then another logical application is to penalize bad acting. So you do something, you prove a transaction that was a bad transaction, then your stake will be, at least in part, burned. So this is quite a common thing in terms of supply adjustment. Of course, the other side is minting. So again, we think about minting in terms of centralized finance. It's kind of the same idea, and that is that you're going to increase the supply of tokens in circulation. So in Bitcoin, every 10 minutes, there's some minting, and that goes on until 2140 when there's no more minting. And DeFi protocols are much more general. Minting is different than burning in that there's no right way to think about kind of accidentally minting. So you can accidentally burn by sending to the wrong address, but this is just not possible to do. So the minting would be part of the actual smart contract. So you'd be able to see the rules. So this is also very important. So even though the supply might not be fixed, like Bitcoin, you actually know it's very transparent from the contract what the actual rules are in terms of the inflation. Okay, so these rules can be directly encoded into the smart contract. So minting, we'll talk about in another sense, in that it could be very useful in terms of incentivizing a range of user behavior. So there's one thing that's really different about DeFi, that you can start a new idea and then you can easily incent people to actually use your idea. So download the dApp and we'll give you 100 of the token. Okay, so basically for something as simple as downloading an app, you're paid directly. And then if you use the app, you get paid. Okay, so this idea of minting for incentives is very important, and it just makes it a lot easier to start up. Right? So much more difficult to do this in just the regular world of traditional finance, where the idea of paying somebody to download your app would literally have to go through the banking system, and it would be a nightmare to actually do that. On top of that, you'd have to raise a lot of money to actually pay people in dollars. Whereas a new protocol is minting their own coin. So it's really easy. And there's far fewer barriers to entry to come in and do something interesting. Okay, so again, there's a number of examples here. I've already given you the key example of if you enter a pool, there would be a minting of a token that is an equity token that represents your share. If you exit that pool, then that token, when you send it to the contract, would be burned. Okay, so that is the most tangible sort of idea of minting and burning, and we'll explore that in a number of applications in the course. So let me return to this idea of how minting can actually lead to another type of incentive mechanism. So minting is, again, very common in the world of DeFi. Indeed, there is essentially a competition amongst the DeFi apps. Everybody, is basically looking for the best app to use. And one thing you would look for is the best possible rate for savings, for example. And that might be an interest rate plus an incentive. So there's a competitive market whereby these incentives change to try to attract users to the particular protocol. And we mentioned briefly in the first course this idea of yield farming. So this is basically a situation where you engage in actions to get the highest possible reward. So you've got money in a liquidity pool that's earning some savings rate. You have a utility token. Then you deploy that utility token because it's valuable. It's basically representing, let's say, 10% of that pool. You can deploy that to another DeFi protocol and earn another level of interest. So the very popular sort of thing today. You do need to be careful because some of these protocols are riskier than others. And some people are being taken advantage of, but nevertheless, this is one advantage of having a mechanism like this where you can very easily mint an equity token and then just redeploy it. It is ERC20, which means it could be redeployed in another context. Okay, so next we need to talk about bonding curves. So a bonding curve is basically an algorithmic representation of a pricing relationship. Okay, so you can buy off the curve and sell to the curve. So this is just a mathematical function, and I'm going to go through plenty of examples. This is important stuff in terms of how supply actually works. So let's start with a very simple bonding curve, and it's going to be a linear curve. And again, we'll use our hypothetical token, TKN or token, and that is going to denominate a price of a token that is denominated in Ether. Okay, and it could be anything. I'm just choosing Ether for a simple example. And S is going to represent the supply. So the simplest bonding curve would be token equals 1 or any constant. So this means that the value of token is pegged to Ethereum, 1 for 1. So it's a very, very simple idea. It's just algorithmically set that token represents 1 Ethereum. So if you had Ethereum in a pool, in this pool with this rule, if you send 1 token, then you get 1 Ether and vice versa. Okay, so very simple. It's not a very good one. It's not a great rule because you can imagine that in some other market, and we'll talk about these other markets, in some other market that the value token goes actually well below the price of Ether. So what people would do is just go to some other market, let's say Coinbase, buy token, and then exchange the token, which they bought for, let's say, half an Ether for a full Ether. So it's not a great model at all. So let's do this a little more generally to a linear bonding curve. So a linear bonding curve, a linear equation, has got a slope and an intercept. Okay, so the slope is m and the intercept is b. Okay, so let's consider a very simple linear bonding curve where the slope is 1 and the intercept is 0. Okay, so again, this is a function of the supply. So it's 1 times the supply. So the first token would cost you 1 Ether. The second one would cost you 2. The third one, 3. Okay, so this is a very simple linear bonding curve. And it is constructed in a way that the people that are buying token early on are getting a really good deal. So if you're the first in, you're only paying 1 Ether. But if you're the third one in, you're paying 3. Okay, so it is a way to incent people to get in early. So this is an example of a linear bonding curve with the equation that I suggested. And here, Alice is going to buy 5 token. And the cost, we already went through the cost of the first and the second and the third, but if we just add it up, the 5 tokens are going to cost 1, 2, 3, 4, 5, and the total amount that Alice is going to pay is 15. So then, so Alice is the first one in, and Carol is the second one, and then Carol is going to buy 5 token. So the cost for Carol, that 6th token, is going to cost 6, and then 7, 8, 9, 10. So to get the next 5 is going to cost 40 Ether. Okay, so now suppose that Alice, as the first one in, decides to sell. So after Carol buys, and there's a total of 10 outstanding, then Alice decides to sell her 5 token. So the revenue that she's going to get off the sale is 10, 9, 8, 7, and 6, a total of 40. Okay, so think about what's happened to Alice as she is like the first one in. So she actually paid 15 for the 5 and was able to sell. Again, this is completely algorithmic. There's no broker or anything like that here. It's completely algorithmic. So the revenue from the sale is 40, and what she paid was 15. And given that she was the early investor, she actually makes a profit here of 25 Ether. So this is just an example of a linear bonding curve. So just to be clear here, this is a smart contract. So this isn't trading with a broker. This isn't trading on Coinbase. We're essentially doing an exchange here. So we're buying a token, and we're actually swapping. So we're swapping Ethereum for the token and the token for Ether. Okay, so this is basically an example of decentralized exchange. So this is, again, a very significant innovation because we're actually doing this without a broker, without a middle person at all. So this is a very simple bonding curve, and essentially what's happening here is traders or users are purchasing the token. The bonding curve is escrowing the funding. Okay, so when Alice and Carol were buying, the contract is escrowing the ether. And then that ether is deployed to actually pay back a little later on. So, so this is a powerful contract and idea in general. So we could actually think of a different way of doing this. So we looked at a linear curve. We could do like a super linear curve or a nonlinear curve. And this is a quadratic curve. So let's kind of go through the mechanics of this. So in this particular equation, we've got, instead of the equation that we had with the intercept of 0 and the slope of 1 times s, now we've got, again, no intercept, but m is also 1, but s is squared. And you can see the dynamics. So for example, Alice buys 2 token. So, and this is minting, right? So 2 token are actually created. So what is the cost? The first one is 1. The second one is 4. So 2 squared is 4. So the total cost for Alice is 5. And then Carol jumps in, and she wants to buy another 2 token. Okay, so into the contract, Carol puts 9 for the third and 16 for the fourth. So total cost of 25 ether, and the contract prints 2 tokens. So now the total supply is 4 token. So now, just like the previous example, Alice decides to sell her 2 token. So this would be burning. Okay, so those 2 token go back to the contract. The 2 token are destroyed, and Alice is able to essentially come up with the revenue in that burning. And the revenue essentially is going to be 16, and that's the 4th token. And then 9 is the third, so total of 25. So the profit for the early buyer, which is Alice, is going to be that revenue from selling, which is 25, minus the additional, the initial cost, which is 5. So the total profit is 20. Of course, I've shown you 2 really simple examples, and this is a much more general idea. So this is an example of a logistic curve. So the idea here is that there are strong incentives early on. So early on, it looks super linear. So you want to get in early because the price is really cheap in terms of token. However, the curve flattens out at some point. And that's what a logistic or sigmoid bonding curve actually looks like. So, and it's much more common to have a function like this, where essentially a lot happens within kind of a narrow range. But the same idea applies as the previous examples. It's also possible to have a different bonding curve for buying and selling. So again, this is very general. It's just an algorithm within a contract. And if it happens like this, there's actually a spread. And where does that spread go? Well, the spread is kept by the contract. Okay, so it basically adds to the escrow. So there's many different possibilities in terms of using these bonding curves.